Voilà, ça y est. Ouais, parce qu'il y avait un truc sur pause là. C'était sur pause.
And utilize video in place of certain GCSS and CSS sessions. Purely, it's being done by myself, Captain Burdick, and Captain Steele, who's behind the camera, purely to see whether it has any possibility of working as a useful training aid. So we're assuming that we have come to the aircraft, we've done all our pre-flight planning and briefing, and we've come onto the airplane, looked at the technical log, discovered that they had to change a wheel on the starboard undercarriage. So we've then done our external checks, paying particular attention to where the engineers have been working, come back on the airplane, and we've just got into our seats with the aircraft effectively dead. We have external power available, but it's not actually on the bus at the moment. During the external checks, of course, we made sure there were no cowlings on any of the APU parts, so that we are in fact free to start the APU now. So we've completed our external checks. We want to put the external power on, couple the external power to the aircraft. It is available. We're coming up here to check the external power, select external power, check the volts and the cycles, they're good. So we can accept the external power. So that's the external power coupled to the aircraft. Now I'll turn the batteries on. I'll just repeat the squib check and the loop check on the overhead panel. We'll see the indications on the cam later. And now we can start the APU. So the master switch is going on. We know that it's safe to start from outside, and we'll push the start button on the APU. We've got an SGU failure here at the moment. Of course, before we start the APU, we would have checked that we have at least a quarter full on the quantity on the lateral panel there. So the APU is accelerating. It's a shame that's broken, because we could see it all coming up on the cam there. One would have expected the APU to in fact have started by now, I think. Ah, it's available. Okay, the APU is available. Let's have a look at the volts and cycles from the APU. That's fine. So we go back to emergency. And now, having started the APU, we're all conscious of the fact that we mustn't turn the pitch trim levers on until all the computers have completed their self-test. There is an OEB about this. The actual time is about 4 minutes. But why don't we keep to round figures? We'll start the stopwatch, either here or here, and we'll run the chronometer for 5 minutes whilst we get on with the rest of our checks. So now I'm going to right back.
Okay, Fred, well, one of the things I've noticed is that a lot of people have a great deal of difficulty with the aircraft clocks. They get onto the aircraft and find that either the date or the time is wrong. It seems to cause considerable problems putting those matters right. Perhaps you'd be kind enough to show us how to do it properly.
Yes, I know exactly what you mean, and I've noticed the same problems myself. The clock is a complex little beast. We'll start by looking and seeing what we have on the clock. Starting from the top, we have the button marked date here, another one marked GMT in very small letters, and then run, hold, slow and fast. And on some systems we have a sync position here, which enables the captain, who doesn't really like setting his clock, to synchronize straight to the first officer, who we assume has done it correctly. Coming down this side, we have run and stop for ET, which stands for elapsed time, and the chronometer here, which is just the stopwatch, which we can start either there, stop it, back to 0, or we can start it here on the control column. Start, see the needle moving, stop it, and and back to 0. But the question was, how do we set the date and the time? Well, I'm going to push the date button, and you'll see that this time showing 17:39 and 40 seconds is, it may or may not be right, I'm not sure. Anyway, we would of course start with the date, and the date is presented to us underneath. In fact, there's another set of figures underneath this GMT presentation where the date is shown American style. So if I push date, we'll expose those figures underneath. So here we go. Now we see 2/12. So that in fact says the 12th of the second month, which is February. Just to show you the functioning of the months, what I'm going to do is move the GMT button round to fast. We use this button both for setting the time and for the date, and the fast position corresponds to the month when setting the date. So I'm going to move this GMT knob round to fast. I'll move the GMT knob round to fast, and you'll notice that the months will start cycling forward. So here we go. There, GMT knob is in fast, and the months are cycling on, and of course it will count up to 12, then 1, 2, 12, 1, 2. Now I'm going to let it carry on, because the way to stop the months counting up is to move from the fast position to the slow position, which will automatically start the days moving. A little bit difficult to understand, but the next time we get to 2, which is February, January, February, I'll move it to slow. There we are. So by moving the GMT knob to slow, we've stopped the months changing. We're now showing 02 February. Now the days are cycling. Of course, these will cycle up to 31 and then start from 1 again. So the date today is in fact the 20th of February. So when we get to the 20th, I shall release my finger from the date button. 13, 14, 15, 16, 17, 18, 19, 20. So that has got the date trapped. We have the month and the date. But of course you can see, because I left it in the slow position, the minutes are moving. It doesn't matter, we've got to set the clock anyway. So the true GMT time is actually 18:02 and 19 seconds at the moment. So once again, in order to move the hours, we select fast. So we'll select fast, and I'll let the clock cycle through. We'll see, of course, it's going to have to count up to 24 and then continue. 2, 3, 4, 5.
If we let it cycle through like that, Fred, does it affect the date at all?
No, it doesn't affect the date at all.
So there's no rush, in fact, to try and get the right time?
Absolutely no rush at all. So we're looking for the 20th. There we are, we've got the 20th. I mean 2000. It would have to be the same date as the hour. 2000. In fact, that's wrong. Sorry about that, Dick.
1800, wasn't it?
18. So never mind, we'll carry on, and we'll have to let it run right the way through to 18. So we've got the hour correct. I don't know whether you can see my watch on the camera, but it is in fact at the moment 18:03 and 39 seconds. So why don't we set it for 18:05? Then we can put it to hold, and when we get 18:05 on my watch, we can start it. So we can come back to looking at the clock. Here are the minutes increasing, and when we get to 05, we're going to put the GMT switch to hold. 58, 59, 60. Notice it doesn't change the hours. 3, 4, 5. Now we've got it on hold. There's absolutely no drama here. We now wait until we have 18:05 exactly on whatever timepiece you're taking it from. So we've got 04 and 27 at the moment. Does this show up actually?
Actually, it doesn't. No.
No. 33, 34. And once we get to exactly the time we've set here, the time in advance that we've set here, we just select the GMT switch to run. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, run. So there we have the date, February the 20th, and the time, 18:05, and here's one of the drawbacks of the clock. In fact, I don't think we'll be able to see it because of the shadow, but the seconds only move in groups of 10, which is rather annoying because if you've just set the clock, you don't really know that it's running until it has counted 10 seconds. So we're up to 20, 30, and you can see that the time on the watch is the same. Now, how do we... Sorry.
No, I was going to say that all seems fairly straightforward to me. Carry on, Fred.
How do we actually use the clock? Well, we've already looked at the stopwatch facility. We start the chronometer either with this button or with this one here. And I really ought to wait for it to count up at least 1 minute. Okay. So when this needle, quite naturally, once it's gone round 60 seconds, the chronometer will show 1 minute. I'm not rushing this because it may seem an extremely simple part of the aeroplane, but it does give a lot of infuriating trouble. Pilots are not very often required to set it because engineers probably have mastered this technique.
And of course, on this aeroplane, Fred, the clock has more significance than it does on older generation aircraft.
Absolutely. I'll come on to that in a few minutes when we talk about how we ally the clock to aircraft equipment. So here we are, we're approaching 1 minute and we expect the chrono box to show 1 minute. There we are, 1 minute. So to stop the chronometer, we can either use this button or this button. Since I started it with this button, I'll stop it with this. So there we have a time of 1 minute 12 seconds. Once we've observed it and used it for whatever we wanted, we zero it like that. And you notice that when the chrono is zeroed, those figures that were chrono immediately are replaced with elapsed time. So elapsed time is always sitting under the chronometer, in the same way as the date is always sitting under the time. When do we use the elapsed time? Well, if we...
You have to put the tail on before you start.
Yeah. Oh.
You
All
change
right,
the plug.
I've taken the plug out, yeah. Oh, I can't do it then, can I?
Oh
Oh yeah, of course you can. Which is the television?
yeah. That's the television plug, I think. No, that's that plug. No, so that one was being turned on. No. We need that plug. Oh, there we go. Can you do it?
Don't know. Well, we've got all of them, yeah.
Yeah, to get that and that.
Right, so we want channel 8. Right. Now we twiddle this until it's...
To find a fixture. Can I switch on play?
It is on play.
Is it
Yeah.
play?
Dad, what's that red light on, Bob?
Don't know.
Is that the record light?
I hope not.
It is.
Isn't it? Oh shit!
For at least 1 minute.
And of course, if we'd wanted to, Fred, I suppose we could have started the elapsed time and pressed the chrono at the start of a takeoff roll together.
Yeah, very easily, yes. It's sometime in the go levers. If we were to assume that we were at the end of our flight now, so we've landed, closed the throttles, we've taken full reverse, we're cancelling reverse now, as we're just about to turn off the runway. So you cancel reverse, straight forward, stop the elapsed time. You might have been, in fact, using the stopwatch during the approach. So you would have had chrono showing, but you still cancel the elapsed time, turn off the elapsed time to stop, and although you can't see that you've stopped it because you're looking at chrono, you have in fact stopped it. It's there underneath there all the time, ready for you to copy down the actual elapsed time in the air. This elapsed time is moved from stop to run. It automatically zeroes. So if that was saying 6 hours and 20 minutes, the next time you do a takeoff, trigger the go levers, and wind that up, it automatically goes to zero.
One of the other things I find, Fred, is that with the button on the top of a control column, that also causes a lot of problems. People tend to stab at it and they're never really very sure whether the chrono is running or not.
Yes, I know.
Any advice there?
Well, I don't really have any advice other than you've just got to get used to it. We can look at it now and see how it works. Imagine we go over a beacon. We push the button, click. Nothing happens for 1/10 of a second.
I think that's the thing that gets people. They press the button on top of a control column and they see nothing happening, so they immediately press it again, and of course they...
Well, let's go through the cycle of what they do. There, we've zeroed it. So they press it, they see nothing. They press it again. They see nothing. They press it again. In fact, you've got to leave it pressed for 1/10 of a second before it actually moves.
Yes, and I think that's the problem.
It is disturbing. It's we cannot design new stopwatches.
Are you going to do much on the FMS?
No.
Okay.
No, I'm nearly finished, really.
Yeah. All right. Okay. Off you go.
Okay. It's the flight management system, and here our little old-fashioned egg timing type clock is a very important item, because if you notice from the picture we hope you're seeing here, we have the config. In fact, this is for a simulator. You could read through your aircraft engine, whatever performance program you have in, and the nav data, and they are all valid for various dates. And we can see here this one, in fact, is for the 3rd of July to the 30th of July 1986. But this, of course, is a little out of date. But what we must ensure is that the clock agrees with the FMS. So we would have to have a database in the FMS that included the 2nd of February. So between this date and this date would have to lie the 2nd of February. The clock also supplies all the basic time information for the FMS. So that's, whenever you turn the FMS on, you should always, if you haven't checked the clock, check that the clock is correct. Remember that captains rely on first officers to set their clock, so it's no bad thing to do a little cross-check.
That sounds like good advice to me, Fred.
I hope so.
Okay. Number 2. That's right.
Are you ready?
Yeah.
It's released.
Okay, thrust SRS runway. Speed's building both sides and the power is good.
No more acceleration.
100 knots, controls free. Increasing rapidly the speed. Good day. V1, rotate. Positive climb, gear up. Speed's decreasing there.
Okay, increase power. Windshield go.
No,
No, we just
fly
want to
through it.
Following the flight director still.
Notice the rate of descent. Notice you're descending.
100. Increase pitch good.
Okay.
At least 8 degrees.
18 degrees. freeze.
Okay, now push the line.
Now we're through.
Okay, you're out of microburst now, so freeze it.
Okay, pushing it freeze.
Re-energy on takeoff.
Okay, and check out position again.
Yeah. And ask the student if he understood the indications of the transit of a microburst, the increase in, or rapid increase in acceleration, the decay in airspeed, and the descent and the decrease in airspeed.
It's still selected.
Okay, Fred, so we're in the cruise at flight level 360. I suppose it's a nat track or something like that at that level. 0.79 Mach.
Yes.
And we're going to suffer some structural damage. Somebody has left a bomb in a suitcase which is in the aft hold, and we're going to suffer an explosive decompression. Assuming that that's happened, can you show us slowly, step by step, the best way, the most effective way to initiate an emergency descent following structural damage?
Right. So, an emergency descent following structural damage is the most likely cause for an emergency descent. The thought of getting ourselves in a situation through a malfunction of the pressurization system is such a chance that it will never happen, it's not worth considering. So we should be teaching every emergency descent as that following a structural problem. And the way we do that, as you see, we're in nav, we've got the autopilot in, we're flying along, we might be reading our newspaper. We get the bang. First thing, we want to get off the airway, and we want to avoid other traffic on the airway. So what we do, it's a series of twiddle pulls and push pulls, but I'll go through them very slowly. So first we want to turn off the airway. So we twiddle the heading round either way and pull it. This engages heading select, turns the aircraft off the airway. Then we move along to the left. We want to descend. We want to get into emergency descent. So we twiddle the alt selector down, right that far, to any figure, it doesn't matter, and pull it. By pulling it, it goes to level change, we get retard, the throttles come back. They're slowly coming back. Whilst they're coming back, we want to maintain the indicated airspeed at which the bomb went off. So we push that to change to indicated airspeed. We want to expedite our descent, so we push, pull the speed brakes. We then go back and fine-tune the settings. So we want to turn 90 degrees off the airway, so we'll fine set that. 11,000 altitude is safe enough. We've got the speed correct. We would of course check with our safety altitude to make sure that that was okay. Then we just check around to make sure that everything is in order and call for the emergency descent checklist. Of course, because we're doing this slowly, one would normally be doing all this twiddle pull, push, pull. We'd be doing that at the same time as putting our oxygen masks on. So we can quite easily do this with one hand and the oxygen mask on with the other.
Okay, Fred, that was a good demonstration. Shall we do it once more, this time in real time at the normal speed following the explosive decompression?
Right.
So let's assume we've had our explosive decompression and you go through in real time the emergency descent following structural damage.
Well, you better say bang. Give me a starting point.
Okay, bang.
Okay. Twiddle, pull, push, pull. Alpha 77. This is killing me. Mayday, Airbus 123 has commenced an emergency descent. We're up 340. Can you tell me what traffic you have below us on the airway?
Okay, no traffic, you're clear to continue your descent.
No traffic, in that case we're rejoining the center. And we see on our charts that the safety altitude is 5,000 feet. Is that affirmative?
You're clear to 5,000 of a safety height checks.
Roger. Clear to 5,000 feet on the QNH 905.
Understood.
Checklist, emergency descent checklist.
Okay, coming up.
Airbus 123, since you have us on radar, do you want us to maintain our squawk of 77?
Negative. Recycle Alpha 4176, please.
Alpha
You are radar contact.
4176, you have. We will be requesting a priority landing.
And that will be...
We don't appear to have sustained any great damage other than a massive decompression.
Okay, we'll give you a priority landing.
And we can see that the aircraft is maintaining its indicated airspeed. If we'd left it on mark, of course, as we descend, so the indicated speed would have increased with the attendant stresses through the aeroplane. Of course, I would be sitting here with my oxygen mask on. We won't hear anything because the CSS doesn't work.
And I would be talking to my first officer using the transmit switch in the correct way, not the way we have to use it here.
Okay.
This is so clear now why the student choose the simulator in the wrong way. Yeah.
Common errors, Fred, for the initialization of the emergency descent. I mean, what are the common errors that we see on the simulator?
The most common error is to leave mark selected instead of changing to airspeed. The other is to forget to extend the speed brake, which of course is not automatic.
And just to refresh everybody's memory, if we leave mark set up there, what happens?
If we leave mark set up there, as I've just mentioned, in fact, as we descend, initially the mark and the indicated airspeed would be correct, but as we descend, the mark number is maintained, but the airspeed, the indicated airspeed increases, and with that increase, the stress on the aircraft. We would, of course, eventually reach VMO.
Okay, I think that's all understood, Fred. Just once more for our benefit, if you can just talk us through the initialization again, just in stages.
Okay, well, I'll get these back into order, although we're already going down, doesn't matter. So we've got it set up again, speed brake 0. So we'll go through the entry into the emergency descent one more time. Twiddle the heading round to turn off the airway and pull to engage heading select, which you can also see on the then we want to descend, so twiddle to wind the altitude selector down and pull it, which engages level change. Push to change mark to indicated airspeed to maintain that indicated airspeed on the way down. Push to get the speed brakes, free the speed brakes and pull them down. Remember on the 310 it's push and pull, not pull and pull. Check that the throttles have closed. We check that we have Alpha 77 set. We talk to air traffic control, we tell them what our problems are. We make sure whether we don't want to turn off the airway and keep steaming off at 90 degrees to the airway, so if there is no traffic below us, then we want to rejoin the airway centre line, because we know what our safety height is only whilst we're on the airway.
Okay, I think that's all understood, Fred. Thank you very much indeed.
It's a great pleasure.